So our next speaker is Guillermo Sapiro. Guillermo was born in Montevideo, in Uruguay in April 1966. He received a BS and MSc and PhD from the Department of Electrical Engineering at Technion, Israel Institute of Technology in 1989, 1991, and 1993, respectively. He currently holds a position as a James B. Duke Professor with Duke University. He was awarded, among many other prizes, the Presidential Early Career Award for Scientists and Engineers. He received the Test of Time Award at ICCV in 2011. Guillermo Sapiro is a fellow of IEEE, SIAM, and the American Academy of Arts and Sciences. So give a warm welcome to Guillermo.
Thank you very much. I'm humbled by being here. I never studied in Uruguay. I mean, in this university, I left when I was relatively young. But I'm humbled with the company that started before me. I'm going to try to get us back on time. I'm going to tell you in advance that I will not take questions so I can bring everybody back, helping the organizers. That will be my contribution to this conference. So I'm going to be talking about, briefly, this was my keynote on Monday, but those that stay in the hotel sleeping will get to see the 3 minutes video again that you missed on Monday, and those that actually were here will get to see a video that I cry every time I see. So if I don't see you crying, I will get very upset. The second one is I'm going to talk about deep brain stimulation. These two topics have a lot in common, and two things they have in common. The machine learning community has almost not touched them. So the first one relates to Danielle. You are more than welcome to work more on developmental disorders. We need you in that field. It's 1 every 10 child are affected by it. And the second is another field that has almost not been touched, brain surgery. And then I'm going to go into a completely different and fun stuff, which is art, and just give you one example of how we can help children learn art. And then I have to finish, those that know me, with a personal view. Hopefully I will get to it. So let's just watch this video for 3 minutes.
Grayson was our first child.
We thought maybe something was a little bit off pretty early.
We were told the wait lists for diagnosis with autism are really long, and I think they've only gotten worse from friends that I've talked to now.
The computer can see things that the human eye simply can't see. But when I first started doing autism research, the average waiting time for a parent who's worried that their baby or child might have autism is about a year. And so the challenge was, how do we come up with an app to be able to detect those early symptoms of autism, such as not making eye contact, not having normal facial expressions in a child's home? If a child is diagnosed at 18 to 24 months and provided 2 years of intervention, the average IQ gain is 17 points. So this has a huge impact on people's lives. When I met Guillermo Sapiro, and he showed me that we could do what I've been doing in the clinic using a computer, that was an amazing moment for me.
I didn't pick
So
this
I've been
dramatic
doing computer
music,
vision
it
and
was
machine
them,
learning
so.
basically all my life. Using computer vision and machine learning, we wanted to see if we could help create an automatic analysis of autism and autism spectrum disorder.
Guillermo can use computer vision analysis to assess things like facial expression and attention. And so we built a set of movies that elicit these behaviors. And then we can show these on either a smartphone or a smart tablet and use the camera in the device to measure the child's response.
Data gets sent out from the phone to the cloud, and then we would be able to analyze that data, run it through our algorithms to produce our estimates of where the person is looking at. Now that we have this tool, what we hope to do is combine the eye tracking data, the gaze data, along with the motion, and jointly see if they can help in the assessment of the risk of autism.
Families simply don't have access to the professionals that they need. The idea that we could use technology to increase access, that's just a wonderful thought to me.
Every minute, every hour that you're able to implement those strategies, that's helping your child learn that social development and learn it with you. And as a parent, that is really rewarding.
I think that if we can do just a small thing to change one kid, I think I would go to sleep with a smile.
Let's just watch. This is one of the kids playing, and we saw that last time on Monday, and I explained in detail what's happening here. If I were to show you a child that has autism, you will right away see that something is very, very different, even with a simple stimuli like this that was carefully created. So a lot of computer vision and machine learning behind, and just a child having fun and trying to help in screening of developmental disorders. I just want to mention that for full disclosure, as I mentioned Monday, the video was produced by Amazon. They gave us a gift, and many of the universities that are recipients of gift, they want to basically advertise the type of research we're doing. And advertising research that is a contribution to society, I think is also a contribution to society by itself. So that's an interesting thing. So where are we? I'm going to show you that video in a second. As we deploy this in 4 clinics, and I will be happy to show you what's going on. It's a big effort. We also actually went to Africa, and we're going more. And if I manage to move my mouse while looking at the screen, this was supposed to play automatically, but I lost my mouse. So I'm not going to waste that. Oh, there you are. This is a very poor town in South Africa that we ship phones. We brought the families to have a snack while they were being screened with the phones. And at the end, they decided to sing as a recognition to what happened. 50 kids in about 2 hours are being screened by this type of tools. And that's just amazing. I didn't have the opportunity to be there. Now we're going into Ghana and other areas, and I'm much more looking forward. I'm actually probably going to use that as the excuse to go to ICLR. I'm actually going to go there and maybe go to ICLR just to get my ticket paid. But we have other areas where we're also very active that I will be happy to help, and it was mentioned before. So that's a really nice gesture of them. I'm going to go into the other spectrum, which is neurodegenerative disorders. For those that are not familiar, what's shown on the left is your left is something called deep brain stimulation. So don't get too scared. They open a hole in your brain and they insert an electrode and they leave that electrode forever. And that electrode is connected to a battery that is here implanted, and it sends pulses to your brain. And it's FDA approved for Parkinson, and there's over 120,000 people, and we're going to see one that benefit from that. And it's also approved for other motor disorders. It's on clinical trials for depression, obsessive compulsive disorder, anxiety, and other things. So it's one of the holy grails of neuromodulation when we're applying electric signals to the brain to try to regulate it. So this. Now, I might need to get out of, because, oh, there we are. So this is a patient that has the implant.
Demonstrate. This is me with the power on.
He has Parkinson's. He's perfect. He has Parkinson's.
I'm not making happy little faces for the video. These are tests that the neurologists make us do. test our reflexes.
It's a bit low, the volume, but he's explaining,
Moving forward.
these are the exercises that when you go to test for Parkinson, the neurologist asks you to do. So now he's going to do us a favor and turn it off, because as I said, the battery's on his chest, so he can put a remote and just turn it off. This is not fiction, this is not Hollywood, so this is real time what they're going to be showing you. He's turning it off right now. Look at his hand.
Read that, it's shaking too much. So it's almost an instantaneous reaction. I can't control this. Could shake some quality cocktails with the right. The left just looks like the royal wave. My voice is gone. It's harder for me to get words out.
He's going to turn it on and see what happens.
Almost automatically. The power comes back on.
Okay, this is not a trick on time. This is real-time response of a patient. There is less than 10% penetration in the United States, which means people that would just go to the neurology and get this surgery, the surgery is extremely safe. It's just you're awake. I can tell you a lot of things. It's a kind of a scary surgery because you're awake for the entire surgery. And there are reasons why the penetration is so low, and we can discuss them. But I have to tell you that a couple of years ago, we developed tools to improve this surgery and improve access. And it's to our belief from the literature, the first FDA clear technique on machine learning for brain surgery that basically helps doctor to get it to the precise location. And there is a company that is working on this. And just to tell you what machine learning was doing there, it turns out the region you need to go to the brain is actually not visible. So why are you awake is because the brain surgeon is poking your brain until it finds the region. And if the brain surgeon is more interested in going to play golf than in getting a good outcome, and I'm not joking, because they normally want to rush out, or they need to rush out because the OR is only available for an hour, and they might need 5, then they will position the electrode in not the most accurate place. And machine learning today, I'm not saying the future, today, is helping them to better localization of that electrode without actually seeing the target. So machine learning is helping them with that target that this has not been seen. Since then, this was the first FDA clear we got, and since then we are on the 3rd one, and all of them using machine learning for brain surgery, which is kind of scary, but also interesting. So let me just go into a completely different area before I close with 1 or 2 slides. This is something we were very privileged. We were called by the National Museum, which is a museum inside Duke University, to do something with these 4 sculptures. And I learned, and I was an ignorant, that all the sculptures we see in museums, they used to be painted. But of course, the paint left them and degraded, and now they're boring. And these are 4 very important sculptures. Nobody was paying attention to them. So we used computer vision to try to recolorize virtually for people. And you see children there being educated, because while they're colorizing, they're learning about the patterns, the history, how the colors were created, from the physics to the politics. If green was able, no, because the passage to India was cut during that time. So we're educating children by a very, very simple application of computer vision. We're making them go to museums. We're making them not want to leave the museum. And I think that all levels of education, and we saw 2 examples, are very important for children, including art and things that are very different than reading. Both of them are very, very important for educating our planet. Everybody talked about privacy and fairness, so I'm going to skip that. We talked that on Monday. So let me just conclude with just 1 slide. As I say on Monday, everything else was science. This is just my personal view. And then I'm going to give an example of my personal view that just happened 2 weeks ago. If I don't have a position, as many of the previous speakers, that can influence billions of people or millions of people, I can only influence myself, and hardly that, because I have other people in my life that influence me, and I can do a bit of influence into my students. Some of them are creating this conference, so maybe I did something right with them, but I think that social contributions of AI and ethics can start at the individual level, and not just at the corporate or big. I mean, I'm glad that people like Jeff, exactly people like Jeff, can control a lot of people, because it would be very bad if other type of people control a lot of people. So I appreciate, Jeff, that you are the one in that position and not somebody else. We're going to work to keep you there. So at the personal level for the students in the audience, if you can, because not always is possible, depending where you live, you have the option to pick where you work. Today in the United States, it's easier because the job market in AI is so huge that most people can pick where to work. So just pick where to work, because there are companies that are doing incredible contributions to humanity. And we saw 2 representatives today in the morning of such companies. You can try to pick what to work on. Sometimes not the first day you get into the company, but after you prove yourself, you can start picking a bit more. I assume that the corporate people will tell me that's correct, especially if you're good at that. And you can pick who to work with. And this was mentioned before. When you work with certain people, clinicians, educators, you are intrinsically doing more. So we can pick those things. And recently, I learned of people that pick those things indirectly. And our causal person just left the room. But if you read a bit about the recent Nobel laureates in economics, there's a lot of data science and causality in their work. There is the youngest female person getting a Nobel Prize in economics. Apropos our conversation yesterday, a team, the 2 of them married, and a female, and they are using, among many other things, data science and causality to influence poverty, and they have influenced already tens of millions of people with their research. So I never met them. They both actually were teaching my son the week they got the Nobel Prize, so it was a lot of excitement for him and for me to say, hey, I just stepped out from their class. I just bought their new book. But these are people that just have influence by doing data science and machine learning, have influenced society, just picking where to work, what to work on, and who to work on, because it's a collaborative project. So that's a good example of what I put in the previous slides. I want to thank you, and I don't want you to applaud for me. I want please to applaud to the organizing committee that are just awesome. Thank you.